In this video, I'll continue with exercise 1.3 of chapter 1, Relations and Functions. So we'll see the 8th question. Consider f from r plus 2 closed for open infinity given by f of x is equal to x square plus 4. Show that f is invertible with the inverse f inverse of f given by f inverse of y is equal to under root y minus 4, where r plus is the set of all non-negative real numbers. So here it is given f is a function from the set r plus of non-negative real numbers to the set closed interval 4 open interval infinity. It is given by f of x is equal to x square plus 4. We have to show that this function is invertible, and the inverse of this function is given by f inverse of y is equal to under root y minus 4. So it is given f is a function from the set of all non-negative real numbers to closed for open infinity, and f of x is equal to x square plus 4. So from this we have y is equal to x square plus 4, where y belongs to closed interval for open interval infinity. So from this we can find x. So x square is equal to y minus 4, or x is equal to plus or minus under root y minus 4. Here f is a function from the set of all non-negative real numbers to this set. So here we cannot take minus under root y minus 4. So x is equal to under root y minus 4. Since x belongs to the set of all non-negative real numbers. Now let us define a function g from closed for open infinity to the set of all non-negative real numbers by g of y is equal to under root y minus 4. Now we will prove that g is the inverse of f by showing that g of f is equal to ix and f of g is equal to iy, the identity function in x and y. So here g of f of x will be equal to g of f of x is x square plus 4. We have defined g of y as under root y minus 4. So in place of y we have to substitute x square plus 4. So x square plus 4 minus 4. So this is equal to under root x square, which is equal to x, or it is the identity function in x. And f of g of y is equal to f of g of y is under root y minus 4. So this is equal to, in place of x we have to substitute under root y minus 4. The whole square plus 4. So this is equal to y minus 4 plus 4, or it is equal to y, or this is equal to the identity function in y. So we have got, therefore g of f is equal to ix and f of g is equal to iy, which means f is invertible with g is equal to f inverse. We have defined g of y as under root y minus 4. Therefore f inverse of y is equal to under root y minus. The next question, consider f from set of all non-negative real numbers to closed minus 5 open infinity given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse of y is equal to under root y plus 6 minus 1 divided by 3. So it is given f is a function from the set of all non-negative real numbers to this set closed minus 5 open infinity given by f of x is 9x square plus 6x minus 5. We have to show that f is invertible and f inverse of y is equal to this function. So first we have to complete the square and we have to find x in terms of y. Then we have to define g from this set closed minus 5 open infinity to r plus, and then we have to prove g is equal to f inverse. So this given f is a function from set of all non-negative real numbers to closed minus 5 open infinity. F of x is equal to 9x square plus 6x minus 5. So let us complete the squares. So here it will 9x square plus 6x plus 1 minus 5. So here I am adding and subtracting 1 because here we can see that 9x square plus 6x plus 1 is nothing but 3x plus 1 the whole square. So this will be 3x plus 1 the whole square minus 6. So from that we can find the value of x. So this is equal to 3x plus 1 the whole square minus 6. Now y is equal to 3x plus 1 the whole square minus 6, where y belongs to closed minus 5 open infinity. So this implies 3x plus 1 the whole square is equal to y plus 6, or 3x plus 1 is equal to plus or minus root of y plus 6. Or we have 3x is equal to plus or minus root of y plus 6 minus 1. Here we cannot take minus root of y plus 6 minus 1. In that case, we will have x as negative. Since x belongs to the set of all non-negative real numbers, we cannot take minus under root y plus 6. So we have 3x is equal to plus under root y plus 6 since x belongs to r plus. So from this we have x is equal to root of y plus 6 minus 1 divided by 3. Now let us define the function g as, let g be the function from closed minus 5 to open infinity to the set of all non-negative real numbers defined as g of y is equal to under root y plus 6 minus 1 divided by 3. Now we have to show that g is the inverse of f. So for that, let us find g of f of x. This is equal to, here we got f of x as 3x plus 1 the whole square minus 6. So g of 3x plus 1 the whole square minus 6. We have defined g of y as under root y plus 6 minus 1 by 3. So in place of y we have to substitute this function. So this is equal to root of 3x plus 1 the whole square plus 6 minus 1 divided by 3. So let me continue. So we have g of f of x is equal to, so here this plus 6 and minus 6 will go. So we will have under root 3x plus 1 the whole square minus 1 by 3. So this is equal to 3x plus 1 minus 1 divided by 3, or it is equal to x. And now let us find f of g of y. F of g of y is nothing but f of g of y we have defined as y plus 6 minus 1 divided by 3. So this is equal to 3 into root of y plus 6 minus 1 divided by 3 plus 1 the whole square minus 6, because we got f of x as 3x plus 1 the whole square minus 6. So here in place of x we have substituted this function. So this is equal to under root y plus 6 minus 1 plus 1 the whole square minus 6. So f of g of y is equal to root of y plus 6 the whole square will be y plus 6 minus 6. So this is equal to y. So we got g of f is equal to ix and f of g is equal to iy. Therefore, f is invertible and g is equal to f inverse. So we have defined g of y as, root of y plus 6 minus 1 divided by 3. So f inverse of y will be equal to this function. Therefore, f inverse of y is equal to root of y plus 6 minus 1 divided by 3. So we got f inverse of y is equal to root of y plus 6 minus 1 divided by 3. The next question, let f from the set x to the set y be an invertible function. Show that f has a unique inverse. So here it is given f is a function from x to y and it is invertible. We have to show that f has unique inverse. Unique inverse means f has got only one inverse. So let us prove this. Now let us take the contradiction. Let f has two inverses. So we will take f has two inverse and g1 and g2 and we will prove that g1 is equal to g2. If g1 is equal to g2 means then it means f has got only one inverse. So if f has got two inverse g1 and g2, then we have f of g1 of y is equal to the identity function in y and f of g2 of y is equal to the identity function in y. So from this we have f of g1 of y is equal to f of g2 of y. So this means f of g1 of y is equal to f of g2 of y. So which implies g1 of y is equal to g2 of y. So this implies g1 is equal to g2. Therefore, F has unique inverse. So, if F is an invertible function, then it has got a unique inverse. The next question, consider F from the set 1, 2, 3 to the set A, B, C given by F of 1 is equal to A, F of 2 equal to B and F of 3 equal to C. Find F inverse and show that F inverse, the whole inverse is equal to F. So, we are given F is a function from this set 1, 2, 3 to the set A, B, C given by F of 1 equal to A, F of 2 equal to B and F of 3 equal to C. We have to find F inverse and we have to show that F inverse, the whole inverse is equal to F. So, let us take, let G be a function from the set A, B, C to the set 1, 2, 3 defined as G of A is equal to 1, G of B is equal to 2 and G of C is equal to 3. Now we will prove that G is the inverse of F. So from this we have G of F of 1 is equal to G of F of 1 is given as A. G of A, and we have defined G of A as equal to 1. So this is equal to 1. Similarly, G of F of 2 is equal to G of B because F of 2 is given as B and G of B we have defined as 2. And G of F of 3 is equal to G of C and it is equal to 3. Therefore, G of F is the identity function in the set 1, 2, 3. And let us take F of G. F of G of A is equal to G of A is 1 and F of 1 is A. F of G of B is equal to F of G of B is 2, F of 2 is B, F of G of C is equal to F of 3, it is equal to C. Therefore, F of G is equal to the identity function in the set A, B, C. So this implies F is invertible and G is equal to F inverse. Given by F inverse of A is equal to 1, F inverse of B is equal to 2 and F inverse of C is equal to 3. So, we have got G of F is equal to the identity function in the set 1, 2, 3 and F of G is equal to the identity function in the set A, B, C. Therefore, F is invertible and G is equal to F inverse given by these values. Now, we have to find F inverse, the whole inverse, and we have to show that it is equal to F. So, let me continue. So, to find F inverse, the whole inverse. F inverse, the whole inverse is nothing but G inverse. So, let us define a function h from the set 1, 2, 3 to the set A, B, C as h of 1 is equal to A, h of 2 is equal to B and h of 3 is equal to C. Now we'll show that H is the inverse of G. So now H of G of A, H of G of A we have defined as 1 and H of 1 is equal to A. So similarly H of G of B is equal to B and H of G of C is equal to C. Therefore, H of G is equal to the identity function in the set A, B, C. And now let us take G of H of 1. So G of H of 1 is equal to G of H of 1 is A and G of A it is equal to 1. G of H of 2 is equal to G of B equal to 2 and G of H of 3 is equal to G of C is equal to 3. So therefore G of H is equal to the identity function in the set 1, 2, 3. So therefore, we have got G is invertible and H is equal to G inverse, or this implies H is equal to G is nothing but F inverse. So H is equal to F inverse the whole inverse. But here we can see that H is equal to F because H is a function from the set 1, 2, 3 to the set A, B, C, defined as H of 1 is A, H of 2 is B and H of 3 is C. Here F is also a function from the set 1, 2, 3 to the set A, B, C given by F of 1 equal to A, F of 2 equal to B and F of 3 equal to C. So H is equal to F. Therefore, F inverse, the whole inverse is equal to F. Next question. Let f from x to y be an invertible function. Show that the inverse of f inverse is f and f inverse the whole inverse equal to f. So we have to prove this. Let us write the steps. Let f from x to y be an invertible function. So this is given. Then there exists a function g from y to x such that g of f is equal to the identity function in x and f of g is equal to the identity function in y. So here we have f inverse equal to g. Now g of f equal to ix and f of g equal to iy means g is nothing but f inverse. So f inverse of f is equal to ix and f of f inverse equal to iy. So therefore, which means f inverse is a function from y to x is invertible with f as inverse of f inverse. So from this we can see that inverse of this function is f from f inverse of f equal to ix and f of f inverse equal to iy. From here we can see that inverse of this function f inverse is f. Therefore, f inverse the whole inverse equal to f. The next question, if f is a function from the set R of real numbers to the set R of real numbers given by f of x is equal to 3 minus x cube the whole raised to 1 by 3, then f of x is, we have given 4 options. We have to choose the correct option. So let us find f of x. So f of x is f of 3 minus x cube the whole raised to 1 by 3. So this is equal to, here in place of x we have to substitute this function. 3 minus of 3 minus x cube the whole raised to 1 by 3 the whole cube, this the whole raised to 1 by 3. So this is equal to 3 minus, here 3 minus x cube the whole raised to 1 by 3 the whole cube. These two will go, it will be 3 minus x cube the whole raised to 1. So it is 3 minus of 3 minus x cube the whole raised to 1 by 3, or this is equal to 3 minus 3 plus x cube the whole raised to 1 by 3. So this is equal to x cube the whole raised to 1 by 3, which is nothing but it is equal to x. So the correct option is option C. The next question, let f from R minus the singleton set minus 4 by 3 to the set R of real numbers be a function defined as f of x is equal to 4x by 3x plus 4. The inverse of f is the map G from range f to R minus of this set minus 4 by 3 given by. So they are given 4 options. We have to choose the correct option. So it is given f of x is equal to 4x by 3x plus 4. So y is equal to 4x by 3x plus 4, where y belongs to the codomain R. So let us cross multiply. We get 3x5 plus 4y is equal to 4x, or 4y is equal to 4x minus 3xy. So from this we get 4y is equal to x into 4 minus 3y. So therefore x is equal to 4y by 4 minus 3y. So which means we can define a function g from range f to R minus of minus 4 by 3 by g of y is equal to 4y by 4 minus 3y. So the correct option is option B. G of y is equal to 4y by 4 minus 3y. I hope this video was useful for you. Thank you for watching.